Greetings! Now that we've set up our integer programming problem in this screencast, I am going to go and solve in LibreOffice Calc. And so again, this is our oil code drilling problem, where we have two sites that we can potentially construct, and we need to connect 4 targets to those sites. Okay, so let's hop over to LibreOffice Calc and let's solve it. Okay, so our big thing was, our objective was to minimize our cost, and that's going to be in millions of dollars. Okay, and before I can even calculate that, I need to make sure I add my variables. Okay, so let me add my variables. So we'll do yi, okay, and we'll just initialize it with values of 1. This is going to be if, site 1 and then site 2 is prepared. Okay, and then I'm going to say if connected. So this would be xi1. So if each, how do I want to do this? So let's set this up so that I have sites 1 and 2. Let's do xi1 if we're going to connect target. No, how do I? X1j. Okay, so this is going to be if. So let me just label this as target 1, target 2, target 3, and target 4. Okay, let me move my head out of here. So target 1, 2, 3, 4. And so what I want to indicate is if target 1 is connected to site 1 and site 2, so I'm going to do 1 and 0 because I can only be connected to 1. If target 2 is connected to site 1 and 2, I'll just initialize with 1 and 0. If target 3 is connected to site 1 and 2, initialize with 1 and 0. And if target 4 is connected to site 1 and 2. Okay, so there's all my variables. And so then my cost is going to be sum over, and so first I'll do product of if a site's prepared times the preparation cost, plus, so then if target 1 is connected to site 1, there's going to be that drilling cost. If target 1 is connected to site 2, there's that corresponding drilling cost. If target 2 is connected to site 1, that's the cost. If target 2 is connected to site 2, that's the cost. If target 3 is connected to site 1, there's the cost. If target 3 is connected to site 2, that's the cost. And if target 4 is connected to site 1, there's the cost. If target 4 is connected to site 2, there's the cost. Okay, alright, so that's what we're going to want to minimize. Now I need to add in our constraints. Okay, and so our constraints are basically going to be, we're only going to connect each target to one of our sites. So it's going to be, whether or not that site's prepared times connection from target to site, and that's going to be sum over both sites, and that has to be equal to 1. So it'll be, so let's just say we'll have a constraint for target 1, target 2, target 3, target 4. Okay, and so in all cases, it'll be whether or not that site's prepared times target 1 connecting to site 1. So whether or not site 1's prepared times connecting target 1 to site 1, plus whether or not site 2 is prepared times connecting it to target 1. Okay, and that's going to be equal to 1. Okay, and I have to do that for for all cases. So we have target 3 and target 4. Okay, so there's our connection constraints. Then we'll have non-negativity, which I'll just apply via checkbox. All variables are integer. We can do via checkbox, or I can group them as well. And then all of our variables have to be less than or equal to 1. Okay, and so we can get these in some of these groupings. And so I'll just do Tools, Solver. I'm going to minimize that. I'm going to do it by changing. I'll select all my variables. Okay. And then I can do these all in a group. Since these all have to be equal to 1, I'll do left-hand side is equal to right-hand side. Okay. Just like I can do these all in groups where I can say that all of my variables are going to be greater than or equal to 0. I'll apply non-negativity in that way. All of my variables are going to be less than or equal to 1. And all of my variables are integer. Okay. And so I could have applied non-negativity and integer via checkboxes, but we'll just leave it at that and see what happens. No solution was found. Okay. So let's revisit this. So that should be right, that should be right, that should be right. Okay. I'm going to minimize that. Okay. So let's check that we have everything. So whether or not it's sites prepared times preparation cost, what's my G times F, then whether or not targets prepared times its cost to connect, that should be right. So I'm going to minimize that. Okay, G3 times H3. That should be equal to 1. Okay, and let's start by maybe breaking our constraints. We're not connected. Okay, and let's just see if I start with a different initial guess. Oh, everything was deleted. So I want to minimize B6. I'll minimize that by changing all my variables, subject to the constraint that left-hand side is equal to the right-hand side, which is just 1. All of these variables, and actually we can just go ahead and we'll check our integer constraint and non-negativity, and then I want to require that all my variables are less than or equal to 1. No solution found. Huh. Let's make sure we've got this right. Non-negativity, all less than or equal to 0. integer. That should be right. Okay, that to a minimum. Try one more time by changing all of these. Require that the left-hand sides equal 1. I'm going to require that all my variables are less than or equal to 1. Okay. Let me see if I do nonlinear and I assume variables as integers and variables as non-negative and solve. Now I get a result. Okay, so I get that I could build sites 1 and 2. Sites 1 and 2 are connected to site 1, and sites 3 and 4 are connected to sites 2. Yeah, for a cost of 18. Okay, so we got it, it works. What was going wrong is my constraints are equal to product of two variables. Okay, so it's a product of two variables. So now when I went to solver, I had to use the nonlinear solver as compared to the linear solver. Okay, and so all it was is I had to change to the nonlinear solver. Now that the problem was nonlinear, okay, my objective function is linear, my constraints are nonlinear due to multiplying the values of my two variables together. Okay, but that was it. So our model then is correct. We get the correct answer. So all is good. So hope that helps. This is one where we had to change to modeling the system as nonlinear.